Hello everyone, I'm Shipeng who is leading the financial benchmark task force in LDBC. And I feel sorry I cannot join the meeting on site with you guys. But maybe we can meet sometime in the future in another Tuesday meeting. So before I start my talk, I would have a simple introduction about me, and I'm currently leading the LDBC Financial Benchmark Task Force, and also contribute to the LDBC as a board director. And I'm also a technical expert in TUC TMAT and group, and I read code and also work as open source development relationship advocate in TUGraph. So when we talk about the financial benchmark, the first thing to say is about the motivation. So as we all know, the graph database plays a pivotal role in the fintech industry. So but currently the benchmarks like the SMB and the benchmarks they cannot capture the unique characteristics of the financial data set and workload. So when we apply this kind of benchmark to evaluating the graph database in financial scenarios, we found this is not adequate for them. So based on the practice we using graph database in Ant Group, we propose this new financial benchmark, which is a novel benchmark we designed with unique features in financial scenario, and we also adopt a choke point driven design methodology by LDBC, which we emphasize performance bottlenecks and the distinct features embedded in the scenario. So here I just list a table to compare the features in each benchmark, like the FinBench and the SMB benchmarks. Here I just compare the FinBench with SMB Interactive version 1. And we can see financial benchmark in financial scenarios, there's some unique features from the data sets, from the query and the workload. In data set, we found there's multiple ages existing in the same vertex pair. We call it the age multiplicity. And we also have the delayed operations in the benchmark. And in the queries, we have some path finding, the temporal window related queries, and recursive path filtering. It's a feature we found in the financial queries, and also we applied a truncation methodology to limit the computation resource consumed when we traversing the graph. And another thing to mention is read-write queries, which is also a common queries we found in the financial scenarios. And also when we're mixing the queries to orchestrate the workload, and we applied a time-biased query mix methodology, which I will introduce to them later. So first, let's take a look at the dataset schema. So here I just present the diagram of the data schema, and you can see the dashed arrows, and the dashed arrows here means the single age, which they do not support, or we do not find the age multiplicity in this kind of age, like only the person can only own the account once, and but like the ages, the of type transfer and withdraw, there can be a lot of transfer agents between accounts to accounts. So this kind of phenomena we call it the age multiplicity. And to summarize this schema, the vertex when we design the schema for financial scenarios, the vertex are usually the entities, and the edges are usually the interaction or the activities involving them. And so this kind of graph is a asymmetric dynamic temporal graph. For each edges, almost all the edges in the schema, we have the time step field or properties to describe the time of the activity. And we also do some profilings on our clusters deployed in the production environment. And we found also find the scaleness in the degree distribution following the power law. And another thing we found is we also profiled the multiplicities of the high degree vertex. For these kind of vertex, their multiplicities also exist the power law, the scaleness in the multiplicity distribution. And let's when we turn to the queries, we found some interesting features like the temporal window filtering. It's easy to understand that when we query the data in the financial data set, we often limited the results or filter result with specified time, start time and end time. And as I just mentioned, we designed following the choke point driven methodology. So here we summarize this kind of methodology. This kind of choke point here is when we trying to optimize or handling this kind of temporal window filtering queries. So here the choke point I list here is the temporal access locality and the performance, which means if you design your system with temporal with a good locality when we access temporal fields, it will have a better performance. And another feature in the query is recursive path filtering. The recursive path filtering means that usually when we tracing some, the font flow or something like that, when we often describe this kind of flow as a path, right? And this path or the filters in when we query this path is it's a monotonic orders, like when we filter the path from the source vertex to the next step, next hop, we are expecting the path each edge in the path is in ascending order in the time step and the descending order in the amount order, yeah. And so it's kind of similar to the RPQ problems in the pattern match. And when we take a look at this kind of problem, if you can apply some filter push down to tag to the path, the intermediate result in your system as the embedded path, you can get some benefit from this kind of push down methodology. And also to express this kind of filter with in the current graph query language like the G code, the Cipher, we find it's hard to express this kind of recursive path filtering concisely. So another choke point is in the language expression. And the redirect query is a common query found in the financial scenarios that usually the complex read query here, it represents risk control strategies in the financial scenarios. And so the redirect query is kind of the transaction wrapped the complex reads. When we when we received the request to transferring money to the source account to the desktop account, we usually take a look at the risk control strategies, and we will decide if we accept or we just deny this kind of request based on the result we retrieved from the dataset with risk control strategies here. So the trial point here is when you handle this kind of redirect query concurrently, usually you may find some red operation contentions and conflicts. It depends on what the system architecture. Yeah. And finally, the last feature we find interesting is truncation, which we use to limit the computation complexity when we traversing the graph. And usually, we handling the hub vertex in financial data sets to avoid the computation exploration. We just do some kind of truncation, like it's actually the sampling. We just truncate the less important edges to avoid the truncation complexity explosions. And the corresponding trial point here is also the truncation pushdown, the language expressions. And also the patterns in the temporal graph is something new we found in the financial benchmarks. We often retrieve some chains and cycles and trees from the data sets. And for the workload, we designed a time-biased query mix methodology. We just let the length of the temporal window in the complex query to determine how many simple read queries following them. And yeah, and here I just came to the future work. And currently we just submit the FinBench paper last month, and we are working on the new version, the 0.2 release. We are sort the data sets and sort the specification and fix some bugs to release the new version. And we also have some ongoing implementation like TagGraph and the GP Store, which is a new system developed by the G-Store team from Peking University. And also we have another ongoing implementation to the PI role. I'm not sure if the pronunciation is right. It's a system by the professional Crowley, and in the next year, we plan some official audits to Graph and the GalaxyBase. They are also planned some audits to activate the financial benchmark. And for the development of the benchmark itself, we have some new features planned, like the auto benchmarking, and we find interesting metrics which is mentioned in the last year a new paper called High Bench. They proposed freshness to describe the data freshness, the metrics in the H-type system. And we also planned a new workload like the SMBBI workload for the analytic processing scenarios. And finally, I would like to thank all the partners and the vendors in the financial benchmark task force, and to help we going so far. And here is my email and my WeChat QR code. If you are interested in our effort, you can just contact me here. That's my talk. Thank you.